Welcome back. Today's focus is now going to be taking those multiplication skills and applying them to what happens when we divide two rational expressions. Now, I'm hoping you remember way back from, I think this was would have been elementary school even, when you're dividing two fractions. Okay, so let's say I give you something like this. Hopefully you guys remember that's the same as multiplying when you flip them. Okay, so again, you've kind of seen this process before. You saw the basics of it way back in elementary school or middle school. Now we're going to apply it with these, okay? And that same strategy applies. Notice when I'm dividing here, that dividing turns into multiplication by flipping that second fraction, okay? Notice how it flipped on itself, okay? So that's our key strategy today is when we see division, all you have to do is flip that second fraction and then it becomes a multiplication problem. In fact, it is exactly the same as every other multiplication problem that we did just yesterday. So only one new step involved in this process, and then we just get to move forward like always. So let's work on our factoring. So starting with this piece right here. Now, again, I always like to put parentheses around everything as my glue. Okay, whenever you're doing these things, put parentheses around everything because the only way to break your glue is factoring. That top one factors into, let's see here, x minus 5, x plus 4. That bottom piece doesn't factor at all, and this is multiplication now. That top doesn't factor. On the bottom, notice you can pull a 2 out of that bottom. Okay, so now we have everything factored. So now it's time to take into account our restrictions. Now, the key to the restrictions, there is a little itty bitty piece here that's going to be new to you. So for the restrictions, you have to use restrictions on anything that you divided by at any point in the original problem as well, okay? So let me tell you why that complicates things for you a little bit. Here I think you can clearly see that's going to create a restriction for -6. That's going to create a restriction for -4. There's one more restriction though, okay? Because at the beginning of the problem, at the very beginning, I was dividing by that x minus 3. So what ends up happening is because of that, 3 also is a restriction. So when you're looking at these division problems, make sure that you use anything you divided by at any point of the problem. So that's going to mean this down here, and then always that. The entire second fraction needs to be part of your restriction process, okay? Because by flipping it, that means you've divided by everything in that second fraction at some point in the problem, all right? So that's just the little thing to make sure that you remember because you have that additive restriction coming from this division process. Well, now, again, aside from that, everything's going to be the same. Now I just start canceling away. So, taking a look at this, I see the x plus 4s. That actually looks like that's all that cancels. So what am I left with? Well, on top, I have x minus 5, x minus 3. On bottom, I have the 2 and the x plus 6. And that's the end of my expression. So let's do a couple more of these just to make sure you feel comfortable and confident in what I'm asking you to do. Okay? So first things first, let's rewrite this. I'm going to change this into a multiplication problem. How do I do that? Well, I'm going to have to flip that second fraction. All right, so let's get to it, shall we? This top piece right here, okay? Notice both the beginning and end are perfect squares. So I'm just going to go out on a limb and see if that's how that piece is going to factor. So I get 10x, 10x. That does give me the 20x I was looking for. So just remember that if the beginning and end are perfect squares, oftentimes it's going to be a perfect square trinomial situation. Okay? Oh, here I realized I kind of forgot one of my rules. I do always like to go like that. All right. Then x squared plus 8x plus 16. And then x squared minus 9, that is our difference of squares. All right. So now we're going to take a moment. We're going to pause and do our restrictions. Okay, before you cancel, remember that's the perfect time to do the restrictions because you still get to see everything. So this creates a restriction. Now remember that one's one of those little bit more complex ones. So you might want to take the additional work of actually setting it equal to 0 to make sure you get that proper restriction, okay? That one should be obvious. That one should be obvious. And now remember, because we started by dividing, that means these create restrictions too. However, it's two of the same thing, so we only have to write the restriction once for it. Sorry, I need a little bit more space. Now let's do any cancellations. Well, this time there weren't really many cancellations, were there? So when I go to write this out, 2x plus 5 is left. On top, I have two of those. So to write it nicely, I can just write it as squared. And then this left on the bottom. So don't panic if not everything cancels, okay? Sometimes you will have quite a few things left when you go through this process. All right, our next example. So again, the first thing, I'm going to rewrite it. And I'm going to change it to multiplication by going like this. All right, put your glue around everything, and now let's start factoring. On top, I can pull an x out of both of those, that x squared plus 2x. Because both terms have x, remember you can just pull that out. The bottom there is regular two parenthesis factoring. So x minus 5, x plus 2. So I have everything factored. So now let's get to the restrictions piece. What can x not be? Well, x can't be 5. X can't be negative 2. When you just have an x, that's just 0. And then remember, because you started with a division problem, that piece also needs to be taken into account. And there you have all of the restrictions. So now to wrap it up, let's see what cancels and how we can write this more nicely. So x plus 2, the x and the x. So this really boils down to x plus 3 over x minus 5. All right. So again, this should feel just like the multiplication process, just with the little additive piece of the extra restriction and the flipping. Okay. So let's go through a word problem just to give us a more rich conversation to have here at the end of the notes, and then I will set you free. So your community is building a park. It wants to fence in a play space for toddlers. It wants to maximize the area for a given amount of fencing. Which shape, a square or circle, provides the more efficient use of fencing? One measure of efficiency is the ratio of area fenced to fence used, or in layman's terms, area to perimeter. Which of the following shapes has the greater ratio? All right, so to do this, first of all, we have to remember areas and perimeters of our geometric shapes. Now, for a circle, we're not used to seeing that written as perimeter. We're used to the word circumference, right? So just keep in mind when they say perimeter, that is the same thing as circumference. That's where that formula is coming from, okay? So we have our formulas. Now we have to express S and R in terms of a common variable. So in terms of P. So S is going to be P divided by 4. Just manipulated this formula right here. Okay, divided both sides by 4. And then here, what did they do? Well, they took that perimeter and they divided off the 2 pi r. All right. So now we have them written in a common variable. So now let's write the areas divided by the perimeters. Remember, that's the comparison we wanted to make. So here, the areas we left alone, okay, and we're dividing by perimeter. So let's substitute for S and R because we wrote S and R in terms of P, in terms of a common variable. So if I substitute in that step, so basically I'm substituting in this for S, substituting that for R. All right, so when the smoke all clears, okay, so here on this side we get P squared over 16 over P. Well, that canceled with one of those. That's how we just get P over 16. Here we get pi times P squared over 4 pi squared all over P. So that squared cancels with that P. That squared on the pi cancels with that pi. So when all of that smoke clears, you just get P over 4 pi. Now the question is, which is the better ratio? So we want the greater ratio. So since we have both of them expressed in terms of P, that P is going to be constant for both of them, okay? Now, looking at this, so if we're looking for the greater ratio, we're going to be looking to be dividing by the smaller number, right? If you have the same numerator, that means that the larger number is going to have the smaller denominator, okay? So 4 pi, that is about 12.57. So if I'm looking for the greater ratio, well, the more efficient one is going to be our circle, okay? So, again, I know that one is a little bit abstract to think about, but it is how they determine what shapes to use. How can they be efficient with the materials they have and the space that they have to enclose? So, thank you so much for staying with me through all of this. So, please make sure that you fill out your summary and then come back ready to do your practice work for me.